Hey, what's up, people? Okay, so today we're going to be working on the save system. Custom appendless save function, part 2. So yesterday we did what did we do yesterday? Okay, so we continue working on custom appendless save function and associated logic in custom appendless spy. Why is that so loud? I don't know. And we stopped at line 31 in save logic. We stage committed and pushed our changes. So let's go over there to line 31 in save logic and pick back up. First of all, we got some extensions that need to be restarted, so let's take care of that. And alright, so this is where we stopped, so we can remove this. It says determine where exactly inside of the associated methods the function call should occur. I.e., shouldn't it occur at the end after visual movement has been completed? Add this function call with the proper args into pop and clear. Okay, so this is true. We need to figure out the, where that's going to happen, and that's how we finished off yesterday. We were discussing what the best practice would be for this operation. And that relates to save checkpoints and those locations and the associated logic with that. Because this function specifically saves all of the card group and the visual data. Okay, so we have this function is going to get called in append, it's going to get called in pop, it's going to get called in clear, and if we save this before the card is actually visibly moved, aka that would be before this locate func dictionary function gets called. If that does happen, like if we save at the beginning of this function where we currently have it located in append, for instance, that's going to register the card as, you know, let's say we're moving from the deck to the hand. So that's going to register the card to be inside of the hand. It's going to save that way. Now, this is before it actually visually has moved from the deck to the hand. So in the case that we were to crash at this location and then reconnect, whenever we loaded in the data, it would say that this card is in the hand, but the X and the Y in the display layer, like the X and the Y location of the card, is not going to be in the hand. So that raises the question, you know, should we do it this way? So this is kind of complicated, because not only are we gonna save through this function whenever we are appending, but we're also gonna be saving when we move the card. But then I guess if you were to put it at the end, if you were to put the save at the end, that it was in the hand after it had visually moved to the hand, and then you crashed. Rather, let's say you put it at the end, the transfer, the saving to the database, and the transfer from the deck to the hand, instead of putting it at the beginning. Well, if you put it at the end, let's say it crashes before it gets to the end of the entire operation. In that case, it would make it to the end. It would make it to nearly the end. It would not actually save the data. See, yeah, I can get myself. Okay. It would not actually save that was transferred from the deck to the hand. That wouldn't be saved in there. But the X and the Y and all that would reflect the fact that it had been transferred to the hand. So there's a little bit of a like, it's either or. You're gonna have a problem either way. So basically, I think the solution here is, I forgot to set the timer. I think the solution would be I mean, obviously we need to save this data. There's no question. It needs to be saved. It's just a matter of when does this save occur. So I think the solution is basically what we had talked about yesterday, where instead of like being hyper focused on picking up at the exact millisecond that we disconnected and like reconnecting intelligently to insert ourselves back into a function at a certain line, it doesn't work like that. That's not how it just doesn't work that way. That would require a lot of precision work, and just like not doing that, not willing to do that, doesn't need to be done, honestly. I think the better option would be to well, so it's the solution that I'm proposing is it's not 100% compatible with like what I had previously proposed. Like, so I'm basically saying that we would have a checkpoint at the beginning of the append function, and then we would have a checkpoint at the end of the append function. If we didn't make it to that last checkpoint at the end of that function, then we simply would throw away everything that happened between. You know what I mean? And we would just start over all over again. We would start over with that append upon reconnect. Now, as I think about that, I realize, well, there's a few things to consider. First of all, appends happen on the server side, and they get transferred over to the client. We're talking client side operation, saving on the client side. So whenever we append a card to a hand from the deck, the append happens server side, it gets transferred over to the client runs the code to apply the data, calls this append function, and that will in turn trigger the checkpoint system and the saving of the data at that checkpoint. Let's just say we'll use that system, only saving at the beginning and the end checkpoint. Now, in that case, how do you, like in the case that it didn't finish, and it was at the the beginning of the append function, or somewhere in the middle before it reached the final checkpoint in append, then whenever you reconnect, how do you know what data needs to be rerun? I.e., like, how do you know what to call when you call the function? Well, we would basically just have to, I guess, save the actual like function call parameters, the arguments rather, because we would basically want to save that the function call parameters. And I'm thinking also about the fact that in the larger scheme of things, like the larger client loop, which this is a small like section of, well, I guess it would just be like a compilation of checkpoints with their each with an individual ID, and I just would really have to be careful to make sure that like I really am seeing how I just have to be really careful with what data gets saved, like, and how to properly reapply the data in these cases of like interruptions at odd places like an append. I would like to think that as long as we had obviously the data, like we have our checkpoint when the data gets received, right? So once data gets like completely received, we would save that received data. We would have a checkpoint there. Then we would have the application section. After that, that's going to be a checkpoint, and this append would fall in the range of the application section, the larger application section. Within the application section, like at the beginning of that process, we would have a checkpoint wherein the data that had been received but not yet applied, all that gets saved at the very beginning of the application section, at like a safe spot, to where you can just do a clean reset in the case that you would need to do that. But then within that, and this is allowing for more precision within like the reconnection process. Let's say we start to iterate through our received data, and we're going to apply each thing one by one. Well, my concern initially with thinking about this is making sure that, because, for instance, one of the received pieces of data would be append this list to the hand or to melds, whatever. And my concern is we would start the append process, like we would save this data that needs to be applied, and let's say the data that needs to be applied at the beginning of the application checkpoint is append this list of 5 cards to the melds, then change the progression text to this, then change enter continued text active to true. So you got those 3 things that need to be applied, and that's like saved, right? Now, once you enter into the next checkpoint, the append checkpoint within that application section, then you're going to first go to append that meld of 5 cards, okay, to melds. Now, when you do that, you're going to have a checkpoint at the beginning of the append, and then you're going to have a checkpoint at the end of the append. Now, let's say you make it all the way through that append. You made it all the way through. You got to the checkpoint. You successfully appended the cards that meld to melds. You hit the checkpoint at the end of append. But then you disconnect before you can get to remove this data that had just been applied from the list of data that needs to be applied. So in that case, you would have actually applied data, but before you were able to save the fact that you applied this data, then you would in fact have disconnected, reconnected, and then it's gonna still show that meld of 5 cards in your list of data that needs to be applied, even though it already has been applied, and then it would redo that process. So a solution to that problem would to be, whenever we hit the final checkpoint in append, that last save checkpoint, we would trigger the save, and that save would include the removal of that data, like from data that needs to be applied. Does that make sense? Now, it's just difficult. It's not easy. This is probably one of the hardest features I've added. It's not easy at all. And the reason that that's difficult is because these actions are like tied together for the proper operation of the game, but they're spread out between all these different files and operations. But like, ultimately we would need we would need a level of precision in the save system like that. Like there's flaws with doing it the way that I've described that would need to be like solved before we could actually go ahead and even test the system with any confidence. So like, let's look at client and let me demonstrate what I'm talking about, because this needs to be thought out before I really continue. Otherwise I'm going to be doing the thing that I say I don't do and that I can't do it, which is adding in code before I've actually like fleshed out the fact that it's gonna work. You know, it's like you're working on developing the new fighter jet and you're not completely sure that the system's gonna work properly to integrate. You're not gonna spend another $30 million to go ahead and just shove the system in there, and then you find out, oh shit, well actually it's not gonna work. We're gonna have to pull it back out and work on it again, and then like it just becomes a nightmare going back and fixing a problem that you created, as opposed to making sure it's not created in the first place. And it's a painful process because you just sit here like this and you have to talk through everything and then brainstorm and then propose this scenario, propose that scenario, and it becomes like frustrating. But I mean, it's really the way that you have to do it, honestly. There's not really a better way, unfortunately. So for instance, we're gonna go with that scenario I was talking about here. Let's see where exactly in the code I would be at. Let's find the application section. So we have receive. Alright, here we go. Application section. So we have a checkpoint. Let's just say we have checkpoint right here. We run that save checkpoint, blah blah blah. Now we go to apply this data. We have our apply list. This contains all the data that needs to be applied one by one. This is going to end up containing that meld of 5 cards and the 2 other pieces of data that we were talking about. Now, once we actually get to this point right here in the apply list, we're going to be iterating through each one in there and applying the data. So that is eventually, let's see if we can find it. Dir check right here. This is where the data is actually going to get applied. So when we call dir check right here, this is going to take in each data piece. First, it would take the list of 5 cards from the meld. It's going to go into dir check, and then it's going to begin the process of appending it's going to append that meld to the melds, which is going to append each card. You know, it's a process, right? So that is what's going to call this append function. And so we're going to have our checkpoint at the beginning of append. We have our checkpoint at the end of append. Let's say it makes it all the way through. It applies all this data. The 5 cards get transferred to the meld. Great job, right? But here's the problem. Let's say we disconnect like, what's this? Current client received caltubulus remove. I have to use remove because received caltubulus isn't a 1-1 exact match. I have to use remove since we can't assume a static index because not okay. But this is, I'm trying to see, is this the list that I'm thinking of? Received caltubulus. Yeah, so we do immediately remove it, right? So this is what I'm talking about. We save, go to append, save at the beginning, save at the end, and then right here, this is when we remove the data from the received caltuplus, which tells us that data has been applied. We can get rid of it. We don't want to deal with it anymore. So at this point, we're safe. But if we were to disconnect right before this line ran, like right here, if we disconnected at this point and then reconnected, whenever we jumped back in via whatever logic we had for our save system for re-entry, it would not have the data removed from the apply list. You see what I mean? So that list of 5 cards would be back in the apply list, because removing it from, well, where is it where we actually remove it from the apply list? Or we recreate the apply list each iteration of the while loop. So I'm thinking, honestly, if when we saved at the end of the append, well, we wouldn't be able to do that because we wouldn't know if it was, we wouldn't have access to the, we wouldn't know whether or not that was like the last card in that particular data point to where we could safely remove it from the apply list. So the saving of the removal from the apply list after the application of a particular data set would have to be done immediately after this dir check call. So we would have to have a checkpoint right here, and that checkpoint would remove the data that we just applied from the apply list, so that when we reconnected, it would know that we were iterating through the apply list, but we had not, well, it would know that we were iterating through the apply list and we had applied the first piece of data from it by the fact that it wasn't in the list anymore. And then it would just pick up and start iterating through this apply list with the next data point being sent past the dir check, which would be that progression text or whatever that we were talking about. But the issue here is making sure that this sort of bugged behavior doesn't occur. And it does require like precision work. You know, we'd have to have this checkpoint right here. That checkpoint would have to know that, hey, we didn't remove it from the received caltuplus, so we need to go ahead and do that. We need to go ahead and get the ID the data was received from, etc., etc. We'd have to finish running all this stuff, which is fine. You know, this is not terrible. I think I just proposed a solution to it. But in the same vein of like not being super precise, especially for our first pass implementation of the system, I think it would probably be smarter, and it would definitely be a lot easier to just to have fewer checkpoints, like way fewer checkpoints at broader sections of the game, which means we would do more reverting back in time, but it would be a lot more stable because, you know, there's just less complicated logic, there's less overall checkpoints, and we can always come back later, and once we've like fine-tuned the basics and verified that we actually are able to get it working, you know, with a level of precision, we can then increase the precision, etc., and make it more specific, and then we can have, you know, checkpoints within checkpoints, like what we just proposed here, where we have the apply section checkpoint, but within that we have specific data point application checkpoints to do all that. But I think, you know, overall, and I'm glad I talked through this and did this, because I think, honestly, what I should do is I should just have a checkpoint at the beginning of the apply section. So we were talking about having one at the beginning of the apply section, and then the beginning of the, I mean, at the beginning of append and then the end of append. But I think it would be better, which unfortunately would mean we wouldn't even use this function that we just created and all this stuff. And I hate to do that because we just spent this time working on this. I mean, it's something that I would want to be done, though. And I feel like it's something that needs to be saved. See, this shit's hard, man. Like, did I just waste my time? Well, I didn't waste my time. I mean, this stuff, ultimately, with the system I want to have, I want to have at least that level of precision. It doesn't have to be perfect to the pixel, but I would like it to be, you know, per card or whatever, at least per meld movement, I would like that to be a checkpoint instead of a checkpoint only per apply. I don't know. That's almost the same thing, though. Like, there's not a lot of difference between having a checkpoint at the beginning of the apply list that handles that versus having a checkpoint inside of the append. Yeah, it's not easy, but I need to make a decision. I gotta decide how exactly I would do this, how exactly I'm going to do this for the first pass. I would say almost certainly adding in a checkpoint per apply, like per iteration. Yeah, basically the same thing as append. So we would have this checkpoint at the beginning of, well, we could have a checkpoint prior to the iteration through the apply list entirely, or we could have a checkpoint at the beginning of each iteration through the apply list. Based on this code right here that I'm looking at, I think it would be okay to have a checkpoint at the beginning of each iteration, and then at the end of each iteration. So in the case that we disconnected, like we have a checkpoint at the beginning of the iteration, so we would save the data that's in the apply list, we would begin to run this, and let's say we disconnected before we got to the end. Well, before we got to the end, we didn't hit that checkpoint at the end of this iteration. Therefore, when we reconnected, it would revert back to this point in time of the first iteration at the very beginning, and then we would just rerun. We would basically just rerun this for loop with the apply list that we had. Yeah, and that's fine. That's safe. There's nothing wrong with that. And yeah, it would just revert everything back to the state that it was. And that is not as precise as the each card being appended checkpoint, but it is precise enough to be a solid first step. Now, I guess I could think about this in a different way. I could think about it in terms of each checkpoint just saving certain data. So let's say we did go ahead and use this function that we this function here that we created, like the system that we were just working on, which is adding in a save into each custom append list method and having that level of precision. As we already identified, the problem with that is the fact that there's certain data inside of there's certain data that isn't inside of this context. Like, we can't save it because we can't save it in this context of custom append list method append, but it would need to be saved and restored with accuracy. And we already went through this apply list thing and how, if in the scenario we presented with the 5 cards being applied, but the 5 cards did not get removed from this current client received cal2 list, or whatever list it is that it needs to be removed from, aka the apply list, to not be to not be reapplied when we reconnect. So, I mean, this is actually not as complicated of a solution, I think, right? Like, we would have this level of precision checkpoint going on, and then we would also have this level of checkpoint precision. We would have a checkpoint at the beginning of each iteration of the apply, and then at the end, just like we do in append. We have a checkpoint at the beginning, checkpoint at the end. And as long as we made it to the a certain checkpoint, to this end checkpoint, then when we reconnect, yeah, but I don't know if that makes sense. I feel like that just makes having the more precise checkpoint redundant. Let's see if I can articulate what I was thinking here. So we have the checkpoint at the beginning of apply list. Then we go to dir check. We start to do append. It's within this context, this function call. We have our checkpoint at the beginning, a checkpoint at the end of that system. And then once we get here, let's say we crash between... Okay, yeah, this is what I was getting at. If we were to crash between the end checkpoint in append and the end checkpoint here, then we would revert back to this checkpoint at the beginning of the apply. Because that means the data didn't happen cleanly. All the stuff that needed to happen, as a unit, it didn't happen cleanly, which means we would have to redo it. But isn't that basically the same thing as saying we would just have two checkpoints, one at the beginning of the apply, one at the end of the apply, to where if it didn't, if it doesn't make it here, restart the application of that data. There's not a difference. So that would basically mean we do have checkpoints at the beginning and the end of the append in this context, but it doesn't actually get used. It's basically it's pointless, right? Well, no, because just like we say there's data in this context that needs to be saved, that has to be done in this context, like the fact that the card got moved from the hand to the meld. When that happens, that data has to get saved there, because how else would we know that occurred? That's why you have to have a save checkpoint in the direct context of where the action is happening. So it's action, save, action, save. You can't save an amalgamation of actions at a certain checkpoint outside of the context in which those actions happen, because the code doesn't know, the program doesn't know. The way that it knows is that you ran the checkpoint when it happened, you saved it when it happened. So okay, that's better. That makes me feel better. That makes me feel like even though we Yeah, I mean, like, yeah, that would need to be saved. Even if it's true that, like, we would have to revert back to the beginning of this iteration through the apply list in that scenario, that doesn't mean that we don't need to save the data, that the actions that occur within the context of the dir check append. That stuff needs to be saved, because when we do successfully finish this iteration, which entails those appends and those actions, which reflects the data, the cards that are now saved as being in the melds instead of being in the hand, that got saved in that dir check append context. We finish this iteration. Now we hit the final checkpoint of this apply list. Bam. Now we don't need to, we don't want to get rid of or ever revert beyond that point, which means, let's say we then disconnect on the second iteration through this apply list, meaning the first apply list iteration, it went all the way through here, it hit the final checkpoint, it saved everything that it needed to save. That's like locked, secure, that data is good. Then when we get to the next iteration, we hit the first checkpoint. Let's say, we crash here in the middle. Now, whenever we reconnect, we're going to want to revert the data, which is, the cards that are in the melds, etc., blah blah blah. All these location data, etc., card group data has to be up to date. And where else would it get it from the database if we didn't save it? Well, we did. We saved it in the context of those append functions. Therefore, when we go to reconnect, we would reapply the data associated with the card groups, which cards are where, etc., etc. And the data would be up to date. So on that second iteration of the apply list, let's say it crashes, bam, when you reconnect, it's going to be able to successfully pick up where it left off, having all the data that it needs. So we do need what we created. Like, what we created is necessary for the level of precision that I want, and it just means that data would only end up being relevant if we also made it all the way to this final checkpoint in the larger context of the apply list iteration. Otherwise, if we didn't make it to that final checkpoint in the apply list iteration, that would cause us to restart from this beginning checkpoint, wherein this dir check data, the append save checkpoint stuff, would be discarded. Now, okay, so there's a lot there, but overall, I think that's good. Like, this system, with how I have it set up in my mind and actually coded in custom append lists and all that, is good to go, and would work, and is what I want and need, and like everything checks out logically, etc. So I think what I'll do is we're gonna put some notes here. And I will remember having this talk, hopefully, and I don't want to write too much. I'll put a note here And you know, we can always, like, this needed to be done. This needed to be done. There's no way around doing this. It had to be done. If I want to actually implement the system, what I just spent time doing had to be done. So let's go right here. And I'm just going to add in some notes here describing what we just laid out. So we have, this is going to be a caution comment, which is designated by 6 pound signs. That's how I do that. And we're going to call this save system, and we're going to say determined that we would need a checkpoint here at the beginning of each iteration through the apply list. All right. We need a checkpoint here, and let's expand on that. And we're gonna say concerning, or this checkpoint will have an associated checkpoint at the end of this iteration. If I can type. This checkpoint will have an associated checkpoint at the end of this iteration. Okay. And then what? Well, we'll have an associated checkpoint at the end of this iteration. If this iteration doesn't make it to the end checkpoint, then data will be reverted back to this point in time. The important thing to note here is that all checkpoints that take place within this context should be discarded unless we reach the final checkpoint in this iteration. And this, we'll put i.e. all save checkpoints that occur within dir check, i.e. dot append, pop, clear, should be reverted back to a previous state unless this checkpoint is reached. And I don't really need to write, like, that has implications in and of itself. So one of the main implications here that I noted would need to be added is accounted for is the fact that we would have data that gets saved to a certain namespace, but we don't necessarily want to constantly overwrite entries. Like, in the context of what we were talking about here, we have checkpoint at the beginning of the supply list, checkpoint at the end, checkpoint for each append that occurs in this dirt check context right here. Now, in the context of that dirt check, we would run the append. The append would save certain card group data under the same namespace. You know, that card group, whatever. P1 melds would have 5 cards in it. P1 hand would have 0 cards in it, or whatever. Now, at the end, if we didn't make it through the final checkpoint in this apply list iteration, the data would need to be reverted back to having P1 hand having the 5 cards and P1 meld having 0 cards, which means we need to have basically we can't have one set of data in our data. We can't have just one data set in the database with a list of namespaces that correlate to each data point that get updated as we hit each specific save point. What we need to have is basically, I guess we would need to have, like, and obviously this has to be fleshed out how we would do this, but we need to have a way to have a prior version of that card group data, etc. So, like, you could say, like, this is the equivalent of 2 save files or 2 save states. But in practice, like, I don't really want to have well, ideally I would just like to have 2 versions, like 2. We don't necessarily have to have 2 databases, but we would have, like, 2 save states in the database. One of them would be, like, the most up-to-date data. That would include the append saves, and then the other one would be the safe fallback save state for if this section doesn't finish all the way, we need to revert back to this point. And then ideally it would just be those 2 states. One would be the last stable state, and then the other would be unstable but completely up to date. So once the unstable but up to date reaches that next checkpoint where it is deemed safe to make it into the last stable state, we would just basically slap the data that's in the unstable but up to date. We would then put that as or we could just rename it or whatever. We just however we would do it, we would just transfer that data to be the new last stable state game state, and then we would just move to the next section, whatever section that is in the loop, and as we deemed, as we created the checkpoints, we would have the proper designations, you know, like the logic implemented to say this is a unstable checkpoint, blah blah blah, whatever. Basically a safe, stable backup, and then just like how we do with working with the files in Git, it's basically the same concept. So I think that's how we'll do it. But before I add that note, let's finish this little section here, and I'm gonna put that we're gonna have. Okay, just paste this in. So I'll put determine that we would need a checkpoint here at the end of each iteration through the apply list, and then now we're going to expand on that and say if we reach this checkpoint, the inner checkpoints, i.e., and we can just like copy this, all checkpoints that occur reach this checkpoint, the inner checkpoints, and we can put save checkpoints that occur within dir check, i.e. append pop clear, should be well, how do we put this? If you reach this checkpoint, the inner checkpoints, save checkpoints that occur within dir check, i.e. append pop clear. So if we reach this checkpoint, this should be considered a new stable save state. I guess we can just put it like that. So yeah, we'll just say it like that. We'll say all of that data would now be considered the new, and we'll just call it like stable save state. And then I'll just lightly touch on the fact that it would correlate to this two save state system, i.e. the unstable save state would at this point become the stable save state, codifying, whatever you want to call it, codifying the inner save state data. And then we'll just put to as opposed to if we didn't reach this checkpoint, we would reconnect, loading in the last stable save state, which doesn't include this inner unstable save state data. Yeah, I think that's enough. I don't need to really say more on that. So let's read that again. Determine that we need a checkpoint here at the end of each iteration through the apply list. If we reach the checkpoint, the inner checkpoint save checkpoints that occur within the dir check, i.e. append pop clear, all of that data would now be considered the new stable save state, i.e. the unstable save state would at this point become the stable save state, codifying the inner save state data, as opposed to if we didn't reach this checkpoint, we would reconnect, loading in the last stable save state, which does include this unstable save state data, reverting back to the beginning, reverting it all back to what it was at the beginning of this iteration. Yeah, that was almost saying too much. What else? I don't know. Okay, so now what I want to do is first of all, we need to put a note here. Well, do we actually need a note here designating the fact that this would be considered an unstable save state? I don't know. Do we need to add that here? Do we need to say, because I don't want to add anything that doesn't need to be added because it just becomes clutter, and then like I don't even want to read it because I just wrote too much and I'm just like, forget it. Most of it ends up here, you know, when I write it anyway, so like I don't really need to read lots of it again. But I want to get out of that habit of just going ham on the notes and just writing too many notes. So do we need to write here that this data is considered unstable? I don't think we actually do, because as long as we know that we have the two states, the unstable and then the stable state, and that this data okay, so so it actually does matter a little bit, or it does influence the code in this section, because this means, well, I don't know exactly how we're going to accomplish this. Probably we would have a separate table, a save data, maybe we'd have like save data stable and then save data unstable, and they're just two separate tables, and they're just contain the same exact data points, except for sections that are deemed quote-unquote unstable sections, i.e. wherein we don't have that logic, the precision logic implemented yet to consider, you know, these sections to be stable. You know, we need to determine where we save the data to, because we're going to have basically two of them. We're going to have the stable and the unstable. Yeah, so I would say that there's some things we could do Like, we could have something that we could have a Boolean that we could that would be called stable true, and or we say stable or unstable, and if this save section is considered stable, which we would check that Boolean before doing any save operations, that would determine where we save the data to unstable or stable. Do we need that? Or would we just be better off saving the data would we be better off just determining, not through some Boolean, but just directly, like in this section, we'll just say we would specifically determine which one we would use. I don't know, the Boolean idea thing is kind of cool because it allows us to always pass the same namespace to a save operation, or to a database write operation rather, and but it also allows us, like, we would just pass in the same namespace all the time. That namespace, however, would change based on whatever it was at that current time. That variable, if it was assigned to true or false or whatever. I don't know if that would actually work with the way. Well, it would have to be a mutable data type. If it wasn't a mutable data type, then that means if it was just like an integer or whatever, it would refer to the value associated with that namespace at the time in which this function like received it, not received it, like was created. At the time this function was created, if save data table was equal to the unstable table at the time of creation, but then we later saved that namespace, save data, to the stable table, then that would not work. It would still refer, save data would still refer to the unstable table. So I mean, we could do that. The point of doing that, I feel like I'm being extra here. I feel like we don't need to worry about this so much. We can just there's a lot of different ways to do it, and I'm just thinking, I'm imagining different ways. One way, so like basically, let's just go over what would actually happen. Once we reach this checkpoint, we would want to save all the data. We would want to basically transfer the data from unstable to stable. That's what would happen. Okay? And then it's really just that simple. So yeah, I don't think we would need to have some Boolean or whatever that determines which one we would save to. I think it would be so like clear cut and obvious. I'm trying to figure out the right words. I think just adding in the code that explicitly transferred all the unstable save state data to the stable save state data, just to happen like that. Like we wouldn't start saving data to the stable. It's not like that. So the Boolean thing wouldn't even work. Now that I'm really thinking clearly about it, it wouldn't work because we're not specifically saving data to it. We're literally would just like basically transfer all the data from one to the other. Yeah, so we would explicitly do it. We would explicitly transfer. So I'll add that. That's probably the last. And then I need to write down these other things that I was thinking about before, like I forget them. And things to do. So this was good progress. It was all brainstorming, unfortunately, but like at least it's at specific points of code, and it's not just like high in the sky brainstorming. It's actually like where the code is going to be specifically, and you know, it's more specific brainstorming than just conceptual stuff that we had been working on. So we need to add here. We'll put therefore transfer all data. I'll just put this. So transfer unstable save state data. Data to stable save state. Yeah. I just want to make sure that I know I need to do that at this point. And that I'm not confused, you know. Okay. So let's go over to things to do, and let's add this in here. We're gonna say we'll call it stable versus unstable states. We'll say database states. But there was another thing. What was the other thing that I wanted to add in here that I didn't forget about? What was the other thing? I feel like there was another thing that I wanted to add in here that was important. Was there not? There wasn't. Being replacing below code section, leave code section true. Being replaced by above function call. Coming inside has been modified. No, I don't think there is anything. I could have sworn, though, man, that there was more than one thing. Unstable save state, stable save state, checkpoint at the beginning of apply, checkpoint at the beginning. What? Okay, I guess I just wanted to write that out about having the checkpoint at the beginning of. Yeah, that's what it was. Okay. Checkpoint let's just say, well, we'll do it specifically, because I was gonna say we need to denote and remember to always work in the context of adding checkpoints in the broadest sense, the broadest scope, and then be more specific and add the more precise checkpoints. That is something that we need to make sure we're doing, because in this instance that we just worked on with the custom append list, yeah, it needed to be done, but it wasn't like the outer layer. We didn't really start where we should have started. We should have started in the broader context of the apply list, and I want to make sure that I do that, because we got lucky and we still do need that data to be saved, but you don't really want to start 3 steps ahead if, you know, on the second step you do the second step after the third step, and then you determine, well, your first and second step was in a different direction, therefore that third step is just, it's bunk, it's not even going to get used. So that's important, but I think really we need to just be specific in this current issue context and put apply, we'll just call this the apply section, save logic, and yeah, so we're gonna add this 2625. Ensure notes in this section are followed concerning proper save logic in client pi apply section. And we just put C lines, number. Well, those lines are going to change, but as long as we're close enough, it should help us. 674 to 678. All right, yeah. And number 674 to 678. We're just say basically using stable versus unstable checkpoints and properly identifying these. Yeah. Okay, cool. And then the last one, I'll just put ensure. This really should be a reminder, but I'll just put it here in current issue so I remember. Ensure broadest scope first for save system logic. Very important. Ensure we are creating checkpoints and logic that takes first into consideration the broadest scope of CS operations, i.e. the just have this on the second line, put i.e. Main client pi file game loop checkpoints. And then we'll just put, like, for instance, at start end of apply, send, receive, etc. Yeah. And I didn't really need need to put these on multiple lines. Instead of within more precise sections that are subsets of these broader operations. Yeah, very important. Okay, cool. There we go. Now, so let's flesh this one out. Stable versus unstable database. Say, create a system wherein we have two databases slash states, one for a stable game state and the other with more precise, up-to-date but unstable data sets, i.e. whenever it is deemed that we have reached the next stable state, transfer data from unstable save state to stable save state. Requires creation of either second database or perhaps a table. All data in upsert operations will be saved to unstable save state. And then we'll just put then whenever it is equal to 6 extra data points. Well, and that's another thing then is add logic. It's really like a subset of that, but we'll just do it as a separate. We say add code in, say determine actual code location for stable save state transfer. Can't type all of a sudden. Adding the extra code which transfers from unstable save state to stable save state. Yep. All right. Cool. Now we're actually done. We're gonna take a break. It's 4:35. I was gonna say 4:37, which is an hour and a half. So 5 hours. 3:06 to 4:37. We continued on. Well, continued on this, but ended up brainstorming, outlining broader save system logic, specifically in client by, let's see, broader game loop, how or where checkpoints would be located and what save checkpoints are considered stable versus unstable. More specifically, added in first pass notes into client by apply section. Added in things to do and things to do, not text, related to this. Alright, now we're gonna stage, commit, and push our changes here. Let's go right here. 438, and this is going to be 439. Alright. It's actually 439 instead. We're going to change this to, let's say, slash broader clients by saves, just put save system logic. Copy that. Alright, now we're in the root of the project directory. We're going to do git branch. We're in the correct branch. We're going to do git add, git commit -m, paste that in. And we use double quotes in our message, which messed it up. So let me fix this. Forgot about that. Get rid of it. Do it again. Git commit -m. Oh, we just made the same mistake. Let's try this one more time. Git commit -m. There we go. Save system comes within the save function part 2, broader client by save system logic, and there we go. We got our specifics, and we did 31 insertions, 4 deletions. So we're going to git push. Just going to push to our upstream remote repository new feature branch, and now we can close this out, and let's go over here to our programming. Go into Canasta, we'll copy this, go back out, delete this old version, then we're going to paste this new one in, go into text, devlog, go all the way to the end, and there we go, that's correct. Go back out here, change this date to today's date, and yeah, there we go. Alright, now that's all done, and I'll probably be back for a second session in a little bit.